Alright, let's do the rest of chapter 29. Suspension system components. We have springs. We have axles, shock absorbers, arms, and rods, and ball joints. Springs. What are springs? Are coil springs or helical springs are used on front suspension in most modern light vehicles. They come in all different shapes and sizes. When pitches vary, deflection rate varies. When the spring has a progressive rate of deflection, which is deflects easily under the light load. So it really depends on how big it is and how small. Size definitely come in play.
Size matters?
Yep. Conical and barrel-shaped springs can collapse into themselves. These springs are one of the oldest forms of springs used on rear-wheel drive vehicles mounted longitudinally. One or more flat springs are made out of tempered steel. Torsion bars, they twist around their center, can be used across the chassis frame or in the trailing arm suspension.
Coil springs are used on the front suspension of most modern light vehicles, and in many cases they have replaced leaf springs in the rear suspension. A coil spring is made from a single length of special wire, which is heated and wound on a former to produce the required shape. The load-carrying ability of the spring depends on the diameter of the wire, the overall diameter of the spring, its shape, and the spacing of the coils. And this also decides which vehicle it is suitable for. A light commercial vehicle has springs that are robust and fairly stiff. On a small passenger car, they are lighter and more flexible. The coils may be evenly spaced, or of uniform pitch, or unevenly spaced. The wire can be the same thickness throughout, or it may taper towards the end of the spring. The spring itself may be cylindrical, barrel-shaped, or conical. Generally, a cylindrical spring with uniform diameter wire and uniform pitch has a constant deflection rate. Its length reduces in direct proportion to the load applied. When the pitch is varied, the deflection rate varies too. The spring is then set to have a progressive rate of deflection. Principles are similar for varying wire diameter and the shape. A spring with a progressive rate deflects readily under a light load, but increases its resistance as the load increases. This gives a softer ride. As conical and barrel-shaped springs compress, they collapse into themselves. This gives a longer suspension travel for the length of the spring than for a cylindrical spring. This gives a softer ride for light load situations and a harder ride for heavy load situations. As a cylindrical coil compresses, it can become coil-bound, which limits its travel. Coil springs can look alike, but give very different load ratings, which are often color-coded for identification. They normally use rubber pads to prevent transmission of noise and vibration.
The leaf spring is one of the oldest forms of springing. It is usually used on rear-wheel drive vehicles because of its simplicity. They can be mounted longitudinally. Leaf springs consist of one or more flat springs made of tempered steel. A number of leaves of different lengths are used to form a multi-leaf spring. They are held together by a center bolt that passes through a hole in the center of each leaf. It is also used to fasten the axle on the spring. The axle is then clamped to the spring by U-bolts that wrap around the axle housing and through a spring plate underneath the spring. Rebound clips are formed at intervals around the leaves. They prevent excessive flexing of the main leaf during rebound and also keep the leaves in alignment. The longest leaf, called the main leaf, is rolled at both ends to form eyes. These eyes are used to mount the spring to the frame of the vehicle. Some springs have the ends of the second leaf rolled around the eyes of the main leaf as reinforcement. This leaf is called the wrap leaf.
Okay.
The front of the spring is attached to a rigid spring hanger on the vehicle frame. The rear is connected to the frame by a swinging shackle, which provides a link between the spring eye and a bracket on the subframe. This swinging link is needed because as the spring flexes and flattens out under load, the distance between the spring eyes increases. Some springs have inserts between the leaves of plastic, nylon, or rubber. They act as insulators to reduce noise transfer and friction as the leaves move under load. Some older vehicles completely enclose the leaf springs in grease. The spring eyes are fitted with bushes, usually with rubber, flexible sections, but nylon and urethane bushes are also used, and sometimes bronze for heavy-duty applications. Rubber insulating pads between the spring-mounted pad and the spring also act as insulators. Similarly, between the spring plate and the spring. The spring forms a flexible suspension unit that fastens the axle housing longitudinally and laterally, can sustain the torque reaction on acceleration and the braking torque during deceleration, and the driving thrust is transferred through the front half of the spring to the fixed shackle point.
The torsion bar extends from the front suspension to a point towards the rear of the vehicle, where it is bolted to the chassis with a bracket. This acts as the pivoting point for the torsion bar. The torsion bar supports the vehicle load and twists around its center to provide the springing action. The spring rate depends on the length of the bar. The shorter and thicker the bar, the stiffer its spring rate. In this application, the other end of the torsion bar is fastened at the front suspension. It is the front pivoting point for the suspension. The lower control arm pivots on bushes. These bushes twist on the lower control arm, which is located in a housing attached to the crossmember. The system also has an upper control arm bush that is attached to the upper part of the crossmember. The lower ball joint is attached to the lower control arm and allows the steering knuckle to rotate as the steering wheel is turned. The lower control arm moves up and down to accommodate movement in the suspension. This particular design is sometimes referred to as a wishbone control arm. The upper ball joint is attached to the upper control arm and allows the steering knuckle to rotate as the steering wheel is turned.
Rubber is used in most suspension systems as bump and rebound stops. If the suspension reaches its limit of travel, these stops prevent direct metal-to-metal contact, which reduces jarring of the body of the vehicle. The stops can also be shaped to provide an auxiliary springing function, increasing the resistance progressively with suspension contact. Some vehicles use rubber as the main springing medium. This rubber cone is this vehicle's main suspension member. Increasing the load on the suspension causes the cone to act like a spring being deformed. When the load is removed, the rubber's elastic properties tend to return it to its original state. Rubber has a number of advantages. It doesn't need to be lubricated, it can be made into any shape as required, and it's silent during use.
Sway bars are used in light vehicles as a stabilizer or anti-roll bar. It's most common on front suspensions, but you will definitely see it in the rear as well. Rubber stops protect the suspension parts when they bottom out. I don't know why I put McPherson struts there because there's nothing to do with it. Axles, they're solid axle, straight axle, which provides extra support and rigidity to keep wheels positions under heavy load. Full floating axle functions only in transmitting rotational torque to the wheels. Semi-floating axles participate in carrying loaded vehicle when placed between the axle and the axle housing.
The solid or beam axle provides a simple means of fastening and mounting the hub and wheel units. Together with leaf springs, it forms an effective, non-independent suspension system. Similarly with coil springs. It is still used in the rear suspension of many front-engined, rear-wheel drive cars light commercial vehicles and as the front suspension on many heavy commercial vehicles. On rear-wheel drive vehicles with leaf springs, the axle housing is held in place by the springs, and no other form of fastening is needed. The drive is transmitted through the final drive unit and axles to the wheels, and therefore the axle is referred to as a live axle. When a vehicle accelerates from rest, the resistance of its mass causes a torque reaction, producing a tendency for the axle housing to rotate in the direction that is opposite to wheel rotation. A similar effect occurs during braking, but with the twisting effect in the direction of wheel rotation. In both cases, this tendency can cause leaf spring windup, and the twisting action can interfere with suspension motion. It is usually controlled by mounting the axle housing closer to the fixed shackle point, so that the spring's front section is shorter than the rear section. The short, stiff front section resists twisting, and a bump stop above the final drive housing can also be used to restrict upward motion during acceleration.
On front-wheel drive vehicles, a simple beam axle can be used on the rear with coil spring suspension and control arms for fastening. This is called a dead axle since it only supports the vehicle and doesn't transmit any drive. It is also non-independent, as deflection of a wheel on one side of the vehicle will be transferred to the other wheel. On some vehicles, this is reduced by using a U-shaped axle beam with a torsion bar mounted inside it. Trailing arms are welded to the beam to fasten the axle longitudinally. A lateral rod prevents lateral movement while cornering, and coil springs provide for suspension. The torsion bar is connected between the left and right wheel units, and deflection of the wheel on one side causes the axle and its torsion bar to twist together. Passenger cars no longer use beam axle front suspension, but it is still common on heavy commercial vehicles and some four-wheel drives. Trucks use an I-beam, in most cases fastened by leaf springs. Four-wheel drives with rigid axles may use leaf springs for front and rear suspension. Coil springs may